Alright, welcome back to the PyCSE channel. Today I thought I would start by showing an absolute beginner approach to using Google Colab to solve a problem. And the problem we'll look at today is finding the boiling point for ethanol using the Antoine equation that is shown over here in this equation. So this relates the vapor pressure, P, to the temperature in the following nonlinear equation, and these A, B, and C are just these constants here. And if we go to the source of this data is this saturated vapor pressure page, and you can see here are the parameters that I chose. And if you want to know what the boiling pressure is, then you really are asking, or boiling temperature, sorry, you're really asking at what temperature is the pressure 760 millimeters of mercury, which is approximately 1 atmosphere. So when the vapor pressure exceeds 1 atmosphere, it starts to boil. And there is a temperature range here in degrees C, and you can see the pressure over here. And if you scroll down somewhere between 75 and 81, we go from 665 to 845, and 760 is in the middle there. And so we can use this as an approximate guess for what the boiling temperature is. Okay, so let's just let's copy this set here that we'll use in a little bit. It looks like this might be the parameters that are relevant for where that boiling point might be. Okay, so now we know what we have to do. We need to find a temperature that makes P equal to 760, and we will use these parameters in the first row to do that. Now, to get to a Google Colab, you need to open up your Google Drive. And we're looking at a Google slide here, so I can look up here and click on this, and this is in a folder called PyCSE, and then I'll just click on open this folder in a new tab. And that will be the folder where those slides are. And over here we click on the plus and go down to more and click on Google Colab. And now we will have a Colab notebook that starts up. Now, if you've never used Google Colab, let me take a minute to tell you what it is. Somewhere in the world, a computer is running that this Google Colab is on, and we can enter code into this cell, and then we'll be able to run it. So what we're going to do is first set up the equation and make a plot to see how does the vapor pressure change with the temperature. And I'll have to introduce a couple of ideas along the way. And so I'll kind of show you a path to get to a solution. So the first thing we'll do is define our variables A, B, and C. And I'm just going to paste in those numbers. And here we can, this is a way of defining the variables in Python. So the first number goes into A, the second number goes into B, the third number goes into C. And we can click on that arrow to run it. And it takes a few seconds when it first starts up. And then we can inspect what each of these things are. So now we can add a new cell. We just put our mouse somewhere in the middle and click on code. And let's put in A just so you can see what it is. And you can see this A has gotten this value. And we could say, check out what C is. C has gotten this value. And B is in the middle. Okay, so we'll delete that. The next thing I want to do is make a plot of that function as a function of t. So let's make an array of t values. Now to do this we have to import a library called NumPy. And we always do it like this. Import NumPy as np, and then we'll say t is equal to np.linspace. And let's go from, say, 0 degrees C to 80 degrees C. And what this will do is make an array of 50 elements from 0 to 80 equally spaced. And we'll take a look at it here so you can see what that looks like. So we just made an array from 0 to this. And now we can calculate a p as np as 10 raised to, and we'll go ahead and look back here. We have a minus b over c plus t. A minus b divided by c plus t. And now this is going to take the a, the b, and the c from up here and use them algebraically like this, and we'll divide by c plus t. And let's have a look there. That's going to be an element-wise operation where every one of these t's gets put into here, and we get a new array that shows we go from about 11 millimeters of mercury to up to 812 millimeters of mercury. And so you can already see from here an almost correct answer. We need the temperature at which the pressure is 760 millimeters of mercury. We have a point here that's 761, which is quite close, and that is a temperature of 78.36. Now, it's not super convenient to do this, and I'm just printing these out to show you. Let's go ahead and make a plot real quick. So we'll say import matplotlib.pyplot as plt. And we will always import our plotting library like that, and then we can make a plot that looks like this. Plot.plot. I don't know why things are moving slow, but it seems like that is something with the internet at the moment. All right, plot.plot, and we want to plot pressure versus T, so T comma P, and it's always nice to put labels on here. Temperature, degrees C. And let's put a Y label on there too. And I'll put a semicolon here so we don't have any output that we don't want to see. All right, now we run this, and this will create a plot, and this shows you that it goes from something that was around 10, nice and smooth, up to 700 or 800. And you can see again, somewhere between 700 and 800, there's a 760. And over here, 760 corresponds to a temperature that is around somewhere between, say, 75 and 80, which we already knew from looking up here. All right, so how do we get a better solution than that? This may be good enough, right? The boiling point of if we look at 76, that's too small. If we look at 78.36, it's a little bit too big. We already know the boiling point to almost within a degree between these two. And if that's enough, you can stop now. But since we're just demonstrating how to do things, we'll take a few more steps. So what we want to do is find out exactly where it is 760. And I know you could do some algebraic manipulation to solve this, but I want to show you how to do it all in Python, and then we'll check. So to find out where it is exactly 760, we have to write a function that it will be equal to 0 when the pressure is at 760. So let's go ahead and do that. F of t, and we will return a value here, which is 760 minus the Antoine equation, 10 raised to the a minus b divided by c plus t. All right, this is a really standard idea that when we have the right t, this term will be 760, and then the function will return 0. And so let's try out a couple of values just to make sure things look all right. Let's try f of 77. And f of 77 gives us a positive number 38. Let's try 78. That gives us a smaller number that's also positive. And now let's try 79. That gives us a negative number. So the correct answer is between 78 and 79. And so that is, again, just consistent with what we've seen. And to solve this now, we import a solver from scipy.optimize. Import, I'll stick with fsolve for now, and fsolve will take the function that we defined up here and an initial guess. So let's put 78 as our initial guess, and now when we run this, we find out that the boiling point is 78.32 degrees C. And that's pretty close to what is known for the boiling point of ethanol. It is something around there. Now, that is like a really whirlwind tour through a lot of things that you wouldn't know automatically when you first start, right? You wouldn't know automatically to import NumPy. For that, you would want to spend some time looking at many of the other videos on this channel to know how you make an array of numbers and to see that you can do this element-wise operation, and then to see that you have to import something for plotting and how to make these plots, and then finally this import for the solving. So as a final check on this, since we will go ahead and work out what the analytical solution is. Let's put in a text box here, and we can write here, we have P is 10 raised to the A minus B divided by C plus T. And I'll go ahead and put this in. Seems like something is running on my computer that's running super slow. Okay, so this is kind of like that. Now, if we wanted to solve this for t, what we have to do is take the log of each side. So we need log 10. So we'll say log p is equal to a minus b divided by c plus t. And that gets us a little bit closer. We can next, we'll say log p minus a is equal to minus b divided by c plus t. And now we can maybe think about dividing the left-hand side by minus b. So log p minus a divided by minus b is equal to 1 divided by c plus t. All right, now we just do 1 over each side, so we end up with minus b divided by log p minus a is equal to c plus t. And then we eventually can see that we subtract c from each side, so we have minus c minus b divided by log p minus a. All right, so assuming I did all those steps correct, which is some days a big assumption, then all we have to do is evaluate that expression. So let's try it out. Let's first just start with minus c. All right, looks good. Minus b divided by log np.log 10 of 760 minus a. And it looks like I did everything correctly because this number is the same as this number up here, out to many decimal places. So that's one of the balances in trying to decide how to do this work. It actually took me a lot longer to work out this derivation, and fingers crossed that it was correct, to get to something that was easy to evaluate as a calculator. And but it required a lot of knowledge to know about this fsolve or the more modern root, and how to set up a function that returns a 0 and that uses it. So that is the end of the little video. I guess here at the end we could replace this with ethanol BP, just so we have a name that is maybe a little bit meaningful. And that is the summary today. It's not a beautiful notebook, but in another video we can talk about how to add different cells that have different markups and look a lot nicer and illustrate what the boiling point of ethanol is. All right, if you like this video, please like it and subscribe to the channel. And until next time, have fun playing around with Google Colab and Python.